Recording is rolling. It is Wednesday, September 10th, Projectile Lab Day. So you guys are going to figure out what is the blast speed of this launcher. And there's different ways to do that, but I'm going to have you guys help to try to narrow the scope a little bit to just one particular setup. So we're going to go out to the balcony in a few minutes after I do the setup with you guys. You guys are going to aim the blaster straight horizontally at the top of the balcony. I got little bouncy balls. Ooh, we get one for the video. Got a bag of bouncy balls here. There we go. Okay. Bouncy ball. So I'll get you guys some bouncy balls here. Pretty sweet. Okay. And then, here's a technical detail. I think I may have mentioned this yesterday. What should you do first? Did you guys see this little compression spring contraction? Should you put the ball in first and then ramrod it? Or should you ramrod it first and then put it in the ball after?
Ramrod first.
Yeah, so let's do ramrod first and then ball. Otherwise, the ball gets jammed in there and stuck, and that's not fun. Okay, so the basic mechanism is this. Okay, you got a ramrod, stick here, and a ramrod. Okay. Now, you can do short, medium, or long range. Guys, do you want to have that variable, or do you want to use the same one over and over?
Same one.
Yeah, same one. So if you do 3 clicks, just keep doing 3 clicks. Otherwise, it's different speeds. And if there's like one blast speed you're after, you want to be, same number. And so then you put the ball in, and then there's this string on top. We lift this, and out goes the ball. Right, I'll fire it straight out. Okay. How fast? Oh, well, that's the question. That's the question. Okay. Now, there's other ways you could set up. So let's brainstorm some ways that you could set up, like other than the way I'm doing it. Okay, great. Could you aim this cannon straight up and say, how high does the ball go? And then based on this maximum height, maybe I'll call it H. Okay. You could figure out the blast speed V from there. Could you do that? Okay. Okay. If you did that, suppose you have a meter stick and it goes up so many meters and you measure that. Okay. If you did it that way, then which of these kinematic formulas could lead you to solve for the blast speed, first, second, or third, based on how high it goes? And you did not use the stopwatch.
Oh, third.
Third one. Yeah, third one. Okay, so here's how high it goes, or like the vertical displacement you can do. Now, you're allowed to know gravity, so can you guys use your favorite version of gravity today? Either 9.8 or 10 meters per second squared. Guys, at the maximum height point, how fast is it moving? Zero. So this VF would go to 0, right? And then this V naught would be the blast speed, wouldn't it? Right? You could do it that way. Right? So I'm just thinking a different way to do it. How about this? Could you have your launcher aimed at an angle? How? Go some blast speed right here. And then you can measure this angle theta and it lands way downfield, and you can measure this distance C downfield, how far it goes. Okay. And if you know this angle and how far it goes, is there enough information there you can calculate the blast speed? Yeah, could do it that way too. Actually, that's exactly what this is. Exactly what this is. Okay. If you want to do real master physics, I might recommend understanding this derivation. Right? This derivation is right here for you guys. Okay. Online, you can download the files. Okay. But the end result is it's called a range formula. So tell you how far x this goes as a function of blast speed. So it turns out, if you do all the math, it ends up being the blast speed squared divided by the gravity field times sine of the double angle. So if this is 30 degrees, 2 times 30 would be 60 degrees. Okay? Now, in this context, if you're solving for the blast speed, V naught, this blast speed, okay, you could have this measured angle theta. You could measure how far downrange does it go. You can measure that with a meter stick or a trundle wheel. Those, okay? And you could also know what gravity is, and you could plug that in. Right? You could solve for the speed. You could do that way. Okay? So I'm just exploring different methods you could use. But I'm not going to have you guys do either of those. I'm going to have you guys do this setup right here. So we'll go out on the balcony. Make this, well, actually, you guys can see the picture anyway. Okay? So can you take a meter stick and measure how high this ledge is right here? Okay? I might recommend walking up the stairs and measure like 1 meter at a time. That is a few meters, and you can figure out how many meters. And then you launch the ball straight horizontal. Now, it's important you do straight horizontal, because if you go at an angle, is it going to land at the same location? No, and that would be different. And that turns out to be pretty complex, because now you got angles, you got vector components, you got too much stuff. I mean, you could, in theory, solve it. It'd just be a lot of paper and a lot of time, right? But if you aim it straight horizontal, it simplifies a lot of things and makes it slightly different. Now, I want you guys to see, sort of like, feel this intuitively. If you know how high this balcony is, and you spot where the ball lands, and you know Earth gravity, do you think it, like intuitively, does it feel like there's enough information just in that where you could solve for the velocity?
Yeah.
Yeah, and it turns out you can. Right. And part of the challenge today, after you guys come back to the classroom, we should have about at least 15 minutes. And let's see if you guys can actually do the math and solve the rest of it. Right. Oh, guys, here's a common question. Should you spot where the ball lands and then sorry, the screen froze. Right, wait, for the screen doesn't freeze. Okay. And then measure from here to here, either with the meter stick or a trundle wheel? Or should you let the ball go bam, 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 and like roll all the way to the library and then measure? Guys, what makes more sense?
Where it's
Yeah, where it first hits, because at that point it ceases to be its initial projectile. Okay, so that point. Trundle wheel looks like this. Now you can roll this across the ground, and it will count. Oh, did you hear that click? Click. But guess how long the circumference is? 1 meter. It is 1 meter. And on this backside, there is a odometer here. Odometer, it's like upside down. Right? So every time it goes around, it'll click again. I think there might be like some way to reset that. But, okay. So if you want to use the trundle wheel, you could, or you could use meter stick. Up to you. So we've been working on projectile puzzles last few days. Those are due when? Friday. Okay. I think I'm going to give you guys tomorrow to pretty much work on those or ask me any questions. So tomorrow will be kind of an open type day. Right? And then when's the quiz? Friday. Right, there you go. Oh, in this free information we did actually 36 is what we did. This is 6. All right. So let's get a table going. So on your paper, write your name. Write your name. Right. Projectile Lab. Okay. You guys got your name. You guys got Projectile Lab. Okay. So question is here's question. So you know what you're looking at. So when you're studying for the midterm in December, you pull this up, like, oh yeah, that's right. That's what this is. This is what that's here. What is the blast speed of the launcher? I'm going to add a little bit to that before I put on the question mark. Okay. For a ball of some controlled mass, I have my triple beam balance right here. It doesn't fit in the camera so well, but it's best I can. So I'm looking for this like seesaw mechanism to zero out. Okay. Now, if I put this little plate right here, right now it's pretty much reading 0. Okay. I put it on the ball. Whoops. Try again. Okay. Put it on the ball. The whole seesaw goes tips that way. Then I can take this 1 gram slider and just slide it. And earlier today, I slide it to about 7 grams. In 7 grams, it goes. And now it's back even. So it's a 7 gram ball. Okay, it's a 7 gram ball. So I'm trying to get it. I pop that in my room if you guys want to play around with that. Sure. What's block data launcher? Say for a 7 gram ball, something like that. Okay, so we know that's ball. Guys, if it was more massive, do you think it would probably not go as far intuitively? Right. That'll be more physical to do in the future, but takes traces, right? Right. Draw a diagram of what you're doing so that again, here we're all on the same page. We know what we're doing. We got the launcher aimed horizontally. Right, we're gonna aim straight horizontal. I'll call this V blast. Okay. This is going to go into what shape is this right here? I'm dashing off. Parabola shape. Okay. We'll call the height of the balcony H. We'll call the horizontal displacement D, or if you want to call it Y and X, you can do that too. Y and X, H and D, it's that kind of up to you. Okay. And then I'll finally help you guys out with some version of a table, some kind of table going on. Okay. Now, how many columns do you need? How many variables should you be measuring or calculating? I'll leave this open, kind of up to you. See if you guys can figure out. What are all the things you think you should be measuring? Okay. All your measurements, by the way, you can make with the meter stick. What variables should you be calculating? And what are the units for these variables? Are you measuring in meters? Are you calculating some number of seconds? And remember, your ultimate question is, what's the blast speed? So guys, what do you think the units for blast speed are going to be? Meters per second. Yeah, meters per second. So at the end, the answer is V blast equals some number of meters per second. That would be the answer. Now, you're going to have to, of course, record some data and also do some calculations to get to that point. All right. So I just need to walk around, get you guys these bouncy balls, and then we will be heading outside.